What would you say if I told you that you could take your whole Arduino board project, shrink it down, and stuff it into one chip, 8-pin little chip that you can buy for, in quantity, you can buy for $1, but under $2. Well, you can if your project is simple and doesn't use certain functions that the Arduino has that the ATtiny won't support. The ATtiny can be made to support some of those functions, like serial communications aren't directly supported by the ATtiny, but they can be added through some routines you can download or upload to the chip. Same with I2 and SPI type communications. Not directly supported, but they can be added through routines. Also, you have fewer pins than you have on a full-blown Arduino. But for a small project, if you want to just dump it into a small chip and have your small project work, then this is the ideal thing to do. This video is about holdups, troubles, tribulations I had in attempting to program the ATtiny, in my case an ATtiny 85-20. And I struggled with this for quite a while, so I'm making this video to hopefully save some people from a few of the pitfalls I fell into. First of all, you're going to need 2 pages of video from the high-low tech pages. And I went and downloaded those pages and copied them so I could use them offline. Up here I have no internet. So that turned out to be a wise choice. Those 2 pages are invaluable. I'll show you those in a second, in brief. They mention a zip file in those pages that you'll also need to download and unzip. There's just one folder in that file that has some definitions for the tinies that you'll need to import into the Arduino, and it tells you where to put them. And that goes pretty easy. I didn't have any trouble with that step at all. Followed the instructions and I got that working right off the bat. So when you go to your boards menu, you go to tools and then you go to boards, you'll have a bunch of new options once you do it successfully. You'll have all the ATtiny options. You'll have ATtiny 85, ATtiny 45. You'll have 3 different speeds for each. And I believe you have some other ATtiny options too for different ATtiny chips. There's some longer ATtiny chips than these 8-pin ones. There's a 14-pin version. It comes in a few different flavors, but I'm not getting into those right now. The genesis for all this came from a project from the MIT, and you can find this project on the pages called high-low tech. And the 2 pages you want are the ones I'm showing here. High-low tech is the site, and within here there's a bunch of links, but the 2 pages that you want is the one called Programming in ATtiny with the Arduino 1.0. That's the one you want. That's the main one you want. And read all this, and then download the zip file they tell you about in here. So you download Arduino software, but then you download the zip file they mentioned in here. Right here. And it tells you how to open up that folder, and once you unzip it, and where to put it. You'll put it in a folder you'll make called hardware, and you'll drop that into your sketches folder. And then the software will know how to find it. So when you go into tools and you go into board, you'll have all these new options for boards that weren't there before. And it also goes through the details of connecting it pin by pin. You have to be very sure you get the pins right. And note that there's physical pin numbers and then there's Arduino pin numbers, which you need to go by the Arduino pin numbers. So like pin 1 is on pin 6, pin 2 is on pin 7, etc. You'll be using these 3 pins for the programmer, plus you'll be using the reset pin to hook to the Arduino board to program this chip. And of course, you know, positive and ground also need to be hooked up. That's basically that page. The other page you need is another high-low tech page, or at least I suggest looking at. And that's the ATtiny. The Arduino board is an ATtiny programmer. So this is basically the same stuff. A little different take on it. A little bigger display of the wiring to the board. More about the capacitor. So check these 2 pages out, read them, try to understand them, download that one file and install that one file. So you have the additional Arduino handlers, ATtiny handlers under boards. Alright, by now you should have been to the high-low tech pages, maybe copied them, gotten that zip file, opened it up, moved that folder into your own hardware folder under sketches, and you should be able to see those ATtiny options in your boards menu off of tools. So let me go over some of the stumbling blocks I ran into at this point. First of all, you've got to know what pins to use. If you're only using 3 pins, the 3 pins or less, the 3 pins you really want to use first are D3, D4, D2. If you need more pins than that, then go on to your D1. You still need more pins, go to D0. You can't really use D5. D5 is used as a reset. The only way you can use it, if you really need 6 pins, and you need to use that pin for D5, then you're going to have to learn how to set the fuses. So instead of just loading the bootloader thing, which actually sets fuses, it doesn't really set a bootloader, using the Arduino software, you've got to get into the AVR Studio software and learn about making your own batch files to set the fuses in a more controlled way, rather than just what Arduino lets you do. And you can actually activate that pin, make it a D5. The thing is once you do that, you've got one shot at programming that chip. Because after you've turned that into D5 and got your program in there, you better hope it works, because you're not going to be able to reprogram the chip without a reset chip. Without a reset pin, you're not going to be able to reprogram the chip. So it's kind of a one. If you really need all 6 pins, you're going to have to really know what you're doing and plan it out. I sure wouldn't do that as a first or second or third step. I'd be trying my program and burning it without that pin, modifying my program so it doesn't need that pin, and then doing it the last minute when I'm sure I got everything else going, all my other ducks in a row. And I found a video from Kevin Dara. I don't have his name in front of me, so I have to go by memory. But another excellent Kevin video where actually I only understood about 10% of the whole video, but it was enough to get me going, so the 10% I did absorb. It was very complex. It was about twiddling the bits, and how you set them all up. And he was using AVR Studio and batch files and stuff that I only barely understand, partly understand. So anyway, you're not going to use D5 unless you're advanced and you really need to do that. So focus on D3, D4, D2, and in my program I'm going to use D1 as well, because I needed 4 pins. If I needed 5 pins, I'd go to D0. But those are your communication pins, that D1 and D0. So I'm kind of reluctant to give those up. And again, you can't give up the reset pin without some major consequences. So other things you need to know next is which pins to use. The other thing you really need to know is that when you get the chip from the supplier, it is pre-programmed for 1 megahertz operation by default. That's very important, because you try to talk to this with an 8 megahertz you know, trying to upload at 8 megahertz or 20 megahertz, it's just not going to work, which is a big share of what I tried doing, because the 1 megahertz routine doesn't work for some of the add-ons. I was telling you can add serial onto this thing with certain routines. Those routines won't work at 1 megahertz. You got to have the 8 megahertz version going. But to start with, you can't talk to this unit at all at 8 megahertz. And don't try to burn the 20 megahertz bootloader. If you do that, the chip's going to go out to lunch on you. You won't be able to talk to it anymore unless you get a crystal hooked up. There's 2 pins reserved for the crystal and 20 megahertz operation. I still have to look into that if you give up the use of those pins for other functions or not, or if you can kind of use them for both. But you would probably give up 2 pins to go to 20 megahertz. And don't even try going to 20 megahertz unless you have the crystal. I've got one chip that I bricked, at least temporarily bricked, because I burnt the 20 megahertz bootloader into it, I believe. It's kind of hard to tell what I did because I made so many attempts that were unsuccessful. I think the 20 megahertz bootloader did take, and I lost that chip. Until I can get a crystal on it, and I may be able to reclaim it. But for now, that chip is bricked. So 1 megahertz by default. That's important. The other thing that's not so important is this shift upload thing. When you hover over upload and go to upload, if you hold shift, you'll see that and you'll see this in my other another clip. That when you hold shift, it'll add to the upload. It'll say upload using programmer will appear after the word upload. So that's an easier way to go than going through the tools menu. You can get to the same options through the tools menu. So in getting going, the first thing to do is to find the Arduino as an ISP program, which is also discussed in the high-low tech pages. But it'll be the same place you go looking for examples. And you go to open and look for that long list. One will be examples. If you look further down the list, you'll see Arduino ISP, and that's what you want to load. That'll turn your Arduino into an in-circuit programmer. Well, no, they call it in-state programmer or something like that. Interstate program. I'll have to look it up what they call it, but they call it the ISP. It's a programmer. The second thing is, I ended up having to use a 22 UHF cap instead of the 10 UHF cap because I just could not get it to work with the 10 UHF cap. Maybe I was doing other things wrong. I don't really know at this point. It's even possible that I had a bad capacitor. I've got a lot of new old stock electrolytics that are 20 years plus old. The cap isn't shorted, so my 10 wasn't shorted, so I don't know if that's the problem or not. But when I started using the 22 UHF, and I read a little bit more over the weekend, and I got it going this weekend, no trouble at all, after trying 2 weekends before with no success at all in many attempts. I set it up this weekend, and first attempt, wham bam. And the 2 things were the 22 UHF cap I tried, maybe. Also by knowing that I had to approach the thing at 1 megahertz before I could do anything. And I got the one chip to talk to me at 1 megahertz. The other chip, like I said, is bricked. I'm not going to be able to talk to that one until I get a crystal. So you want to start with something simple. Don't try to upload a complicated program. Start with a simple Blink program. Make sure you change the pin in the Blink program to work with one of these 3 available pins. And say you use D2 is what I used, and the example I might show you. Get that going, and voila! When you see that thing blinking, you're at some level of success. It was blinking too fast, but at least I knew I installed my Blink program. And I had my Blink program. It's the same one from the last episode where I was doing the tri-state, and that's the version I uploaded into my chip, and it worked. I could see that the green LED was going in shorter than the white LED, and then the pause was longer than either one, albeit they were all very short. They were quite shorter than they should have been for delays. So once I got that working, I went and burnt the 8 megahertz bootloader. And that seemed to work, so I went and uploaded Blink again, although this time with my board set to 8 megahertz. You know, to the tools and boards, 8 megahertz ATtiny. And now it blinked at the correct pace. Pretty much the correct pace. And so then as a 4-step, once I knew I had all this communication going, I uploaded my program rather for the, it is a problem, my program for the ping program, my proximity detector. It's going to be a driveway detector. And I got that working. And at this point I still have the Arduino hooked up to the chip as well as the chip running that program, because I'm doing any little adjustments I might do yet before I call it done. But basically I got it all to work. The earlier version of that program I shrunk down for the Tiny. I was using D5, so I had to change that and went over to D1. So I'm using D1 through D4 basically to run that program. And I got it working. So I'm quite happy. After lots of trouble and toil and trouble. This is my final shrink down of the ping program, where I've deleted all the serial commands, which turned out to be good because the serial commands wouldn't have worked directly on the Tiny anyway. I didn't need them. So it's a pretty far modified program. It doesn't look a whole lot like the original. And I've written it in a form where it'll fit on one screen. Kind of compress things in a little bit. But that's the program I'm burning onto the chip. The last minute change I had to make, I don't know if I showed this program in the ping video or not, but the last little change I had to make was I had to switch alert 2 to pin 1. Originally I had it set for 5. So I learned about the reset issue with the Arduino, the Tiny. So I changed it to a 1. And this program is very small. This could have easily fit on a 45, ATtiny 45 chip, which is cheaper, has half the memory. I think it's an AT25. It probably could have even fit on that. I'm using about a quarter of the memory. You can see in the bottom there, I'm using 1,396 bytes of 8,192 available. So yeah, I'm only using a fourth of the memory, not even. Could use a smaller chip. If I was going to make a zillion of these, I'd order the smaller chip even. So it makes this project very small, very compact, and very cheap. The ping sensor is quite inexpensive too. I think I paid under about $5 for it. I think less than $5 for the ping sensor. And I guess I didn't get the Parallax ping sensor. I got the Stain Smart one, which is why I got the 4 pins on it. And this is the final project, pretty much. I still have the, that's the heartbeat from the ISP, or Arduino as an ISP. Use the 3 status lights are for that. Running in the Arduino still. I'm actually only using the Arduino for 5 volts right now, though, to run my my ping from my proximity detector. So right now the proximity detector is running purely on the ATtiny chip. And if I get in the way, you can see the alarm to go off. One's got a little more distance than the other, but they get like it's 11 and 14 feet. So I've successfully shrinkified my Arduino project down to one little chip. holding the shift key to get this extra using programmer. Trying to upload a revised version. Switch some of my pins around to make it easier to make physically. It's the same program with a few pin switches. Looks like it's working. Should record the flutter of the programmer. I do believe it worked. And here it is all shrunk down and put on a little board. ATtiny in there running the show. Took a bit of time to do though. Troubleshoot all my little errors. I found a couple other good resources online as far as the ATtiny 85 working with it and the programmer go. Electronics.stackexchange.com. This site, if you search for ATtiny in the search box up here, there's just a world of stuff in here. There's a whole lot of stuff I'm learning, and a lot of it's deeper than I need to know even. But a couple interesting things is there's a couple alternate ISPs you can find. One of them is called Scratch Monkey. This one sounds pretty advanced. And there's another one which is just a modified version of the Arduino ISP. See if I can load that one up. Anyway, both of these provide a clock signal generated by the Arduino programmer, which is kind of nice because it can prevent the problem of bricking your Arduino like I did. You'll still need a crystal when you pull the Arduino into its own project, but at least you can, get it back to reality without having to have a crystal. Apparently, I haven't tried it. But a lot of good information on this site about using the ATtiny and getting it to work with I2 and other protocols for communication. So check the site out if you have any trouble, because there's some real advanced information here. I wish I'd found this site earlier.